get the recording started. So it's official.
Yes.
We're talking about calculus and high school and cavities and fun stuff like that. People who were not here will be like, what? Like, trust me, it's related. So you all are new to me. That means that you all are going to be very pleased by the next thing that I have to say. It is the point in the semester where we're going to play Let's Make a Deal. More specifically, last weekend, you would have gotten an email about submitting a university course evaluation. Right now, I have 3 of you who have done so out of 32.
I didn't get an email.
You should have gotten one on Tuesday or on Saturday or so, and if not, you can go into Icon and find it. It's called Spot now. They changed the name of it and made it look different, but it's the same questions.
Okay, I'll try to find it. Thank you.
So here's my deal, and I'm lumping across the 2 sections because that's just an administrative thing. So there are 32 of you. If at least 29 of you complete a university course evaluation, I will give the entire class 1 point of extra credit, like 1%.
Woo!
That's deal number 1.
Can we do it during class?
Yes, that's fine. I don't care when you do it. So as you can see, I will keep an eye on how many people have done it. I do not know who hasn't done it, but I do have the option to send a reminder to those who have not, and I will do that next week. But since you all know each other, you can nag each other and make sure that this works. So that's deal number 1, okay? And to be clear, I am not bribing you to get good evaluations. I am bribing you to get a good response rate.
To do an evaluation.
To do an evaluation. So you can nuke me and take the extra credit. Like, that is within your rights if you want to do that. But I do value your feedback, and I appreciate that it takes time and effort to do these things, and so I'm compensating you for taking that time and effort. It just seems fair. Now, that being said, that's deal number 1. So if at least, what did I say, 29 of you? 29 out of 32. Yep.
Ish.
The entire class gets 1 point extra credit. Because we do not get any choice what these evaluation questions are, and honestly, these are not super helpful, I built a separate Qualtrics survey. Each of you will receive a link to it over email this afternoon, and each of you who completes it can get a 2nd point of extra credit individually.
Ooh.
Whoa.
Bonus.
I know.
Extra bonus.
And the way that it works is that I can download a spreadsheet that shows which emails have submitted a survey, but the responses to the survey are not tied to your emails, so it is
Question.
still anonymous. Yes.
Do you have to be on your Iowa account email to fill it out? Or if it's forwarded to another account, can you still fill it out?
You can fill it out regardless if you click the link that
As long as-
came
okay.
to you.
Okay.
Like, that's
Very
how
good.
it knows what email that was.
Because some of them, if you don't click it from the right spot, they don't take you to the right thing. So.
If it won't let you in for whatever
I
reason, let me
can
know.
just get to the U of IU one. That's fine.
Yeah, I put in all
forward.
your Iowa emails. If you used, Yahoo or Gmail or something like that, I don't have access to that.
Oh, no, that's fine.
But
it's all good. Thank you.
I only use Gmail, actually, and I forward all my Iowa stuff to my Gmail account so that everything is in one spot. And I've done that with every job that I've ever worked so that I have all the emails, put that together. But so those are my deals.
Very good.
The Qualtrics survey is longer. It gave me a very poor rating for it because I had so many open-ended questions. But honestly, this is the point at which qualitative feedback is a lot more useful to me.
Mhm.
So I have more specific questions about your experience in this class, and I've gotten a lot of really good ideas from students from this process. So as an example, the opportunity for the TAs to lead formative assessments was a suggestion that was in a course evaluation one year, and I thought, well, that's a really good idea. I should do that. Another one that I've been using is the idea of saying which slides were covered in a lecture video, not just like whether it's part 1 or part 2. Someone suggested to do that, and I thought, how did I not think of that one before? That's like super obvious. So I appreciate your suggestions. I appreciate your feedback. I do use that in planning the next semester's course. So this version of the survey, the university version, closes next weekend. I think you have 1 more week to do that. I'm going to leave mine open until Thursday of finals week. So you have 2 weeks to work on that, so you can do that at your leisure. All right, any questions on any of that? Good? So your last thing you can be working on then is homework 6. It is open. It is due Thursday of finals week. And I did not get a chance to ask the TAs. Erica's here. Are you planning on holding office hours finals week? She was? Okay. Sam, are you here? I don't see him. Yes, he is.
Mm-hmm.
Are you going to do office hours during finals week?
Yes, I am.
Okay, great. So I have office hours Monday, Tuesday, Wednesday, and Thursday of finals week. The TAs will have theirs. So if you're working on stuff and trying to get caught up, come on in. I want to say ollie ollie oxen free, but I'm not sure if that means anything to you. It's an expression that when you're done with hide and seek and you want people to come out of hiding, that's what you say. And I have no idea what it means. But it's just like a lingering point from my childhood, much like press your luck was last time. Stop at a whammy. Okay. So we have more interaction stuff to talk about. That's what we can be doing. The other thing, I have one more housekeeping thing I forgot to mention. There is a new Lecture 6 for the last day of class that I posted this morning. So it's a kind of a summary wrap-up, and it's called Caveats. Because up to this point, I have said nothing about the assumptions that we have to believe are plausible for our results to be valid. I've said nothing on purpose, because I want to at least give you the breadcrumbs as to when your assumptions are violated, what do you do about it? And there are ways to adjust the models that we're using in that case, but in a lot of cases, you're going to have to jump to a different kind of model. And so just a little bit of that as foreshadowing into future coursework that you might pursue. So I am in, let's see here. What page am I on? 7. This is example 5, page 7. We have 2 more interaction models that I would like to try to get through. We'll see how far we get, and we'll find out, right? It takes as long as it takes. So at this stage, we had examined whether the effects of age and grip strength varied by gender. We talked about that on Tuesday at length, and they did not. So I took those out of the model. I am now adding in a different kind of interaction term. It is between age and grip strength. And I'm saying it's a different kind because both of these are quantitative variables. So rather than talking about a slope differing between groups, this is going to be a slope differing as a function of a continuous moderator instead. So the research question that this interaction term would answer would be something like, does the effect of age vary by grip strength? So in that case, age is the focal predictor, grip strength is the moderator, or I could turn it around and say, does the effect of grip strength vary by age? That interaction term does both of those things at once. And because age has a linear slope and grip strength has a linear slope, it only takes one interaction term between them to examine moderation. As opposed to, if age had a quadratic slope too, then I would need another interaction of grip strength with quadratic age that would allow the full age effect to vary by grip strength.
Do you have to do that if there is a quadratic?
You don't have to,
Okay.
but it would be wise to.
Understood. Cool. Thank you.
And I'm not going to do that kind of model.
Oh, that's fine.
This one's enough.
Just a curiosity.
Yes. Yeah, you can have interaction terms of any kind of predictor, and you can decide what the form of the interaction should be.
As long as you don't need it because of another interaction.
Yes, so in that example, if I had age by grip strength, is what that would essentially boil down to, then I would have to have age by grip as well, because that's within it. So if I have a 3-way interaction, I need all the possible 2-way interactions, just like if I have a 2-way, I need all the possible main effects. It all works like that.
Perfect.
Okay, so any questions on the setup so far, folks? Nope, we're good. All right. So throwing the interaction into our row of fixed effects, it looks like I've got Stata output here first. I think I have it in both packages if memory serves, though. Let me see. Yep, I did. Okay. Not trying to play favorites across the software. Nah, I'm not. I do them in the same order so you know what to expect.
It's good.
Yes.
It's all good. I know I'm the only R person.
No, you're not. There's a lot of folks
Oh,
using
really?
R, right? Who here is using R? 1, 2. Zoomers?
Oh, besides
Okay.
the TAs.
Yes. Well, when I say not trying to play favorites, I'm not trying to emphasize one
One over
package
the
more
other.
over the other. We all know how I feel about R. Like,
Yes.
that's,
Yeah.
that goes without saying. And they're like, yeah, it sucks. But the bad news is that I am the only one who teaches in anything but R in our program. So if you want to take further coursework like design of experiments uses R, Anything Jonathan does uses R and Stan. Erica, how much worse is Stan than R?
I haven't had that much trouble with it, but it is more complicated.
Okay, so
Stan?
Stan. I don't know what it stands for.
I don't either, but it's Bayesian.
Stan, yeah, it's a thing. It's for Bayesian estimation.
Oh, okay.
So it does Markov chain Monte Carlo stuff.
Okay.
Yep.
I'll learn about that at some time.
Yeah, that's like a 9 or a 10 in terms of the level of difficulty.
Well, that's going to be in some stat classes I hope to take at some juncture.
Yes, at some point. But not today.
No.
Not today. All right. So we've got our intercept here is 29. That is the expected cognition outcome for, we can go through the list, someone who's 85, who squeezes 9 pounds, who's a
Man.
dude, who's not going to get dementia, the none group across these two contrasts. And the fact that we have this new interaction term does not change any of that.
Because 85 is already a 0.
Exactly.
Well,
'cause-
and the 9's also a 0.
Yes, so we already had the two predictors that form the interaction. Adding the interaction does not change the interpretation of the intercept. Now, it changes its value because it's based on a different expectation, but it means the same thing. In terms of marginal versus conditional, what's this one? As Zoomers, you can do a C or like an M, maybe. We can do gestures. Or you can type. Yeah, the other
Or,
class
sorry,
wanted to do
this way.
gestures. Yeah, C. Backwards.
Or in the dance move.
Oh, YMCA. Yeah, that song
Sorry.
is dead to me now.
Sorry.
Yes, age is conditional. Now, more importantly, why is age conditional?
It's part of the interaction term.
That's it. So that means the only situation in which this is the age slope is when the interacting variable is 0. So that's what I mean by conditional. This is the age slope controlling for grip, controlling for gender, controlling for dementia. That's the unique part. And that applies to every predictor in a multiple predictor model. But only the ones that are part of interaction terms are not just controlling for, but specific to the 0 value of the moderator. So this is the age slope for somebody who is what? Make it bigger. What kind of person is this the age slope for?
The grip strength of 9.
The grip strength of 9, the other one. That's the tricky part. Yep. Likewise, this effect of grip strength is conditional because of the interaction term. And this would be the grip strength slope specifically for?
85.
Yeah, age 85, the other one. Now, what about the gender slope? Marginal or conditional?
Marginal.
Yeah, because it's not part of an interaction term. So what that means in practice is that the difference between men and women after controlling for this other stuff is 3.5, the end. Like, don't have to say for an 85-year-old or for grip strength 9, this is the gender slope. Who's lower? Yeah, so the MW is my way of saying men are the 0, women are the 1.
That's why you had him first. Sorry. I'm just.
That's my naming notation
I like
thing.
it because
Sometimes I put in a V here if I'm feeling fancy. Like,
but being consistent with oneself as to how you're using the reference group.
yes.
Imagine
So
this.
women are the 1, and so they are the lower one. So when I talk about this, I would say this slope describes how women differ from men. And I have to say it that way or the direction is backwards. Likewise, these two dementia slopes, these are also marginal because they're not part of an interaction term in this model. They will be in the next one, though, so stay tuned. We'll do one at a time. Now, the interaction term, is that marginal or conditional? It's a tricky question. We got 1 vote for marginal. It's 50-50. Zoomers, what do you think? The interaction term, marginal or conditional?
Conditional.
Got 1 vote for each now.
Flip a coin. Find a winner.
Actually, I think we have 2 votes for each now.
Ooh.
Here's my question to you. Is there any other term in the model that has both age and grip at the same time? Nope, then it's marginal. By the same rules. What this means is that this is how grip moderates the age slope for everybody. This is how age moderates the grip slope for everybody. Marginal. They're like, what? That is the what face? I'll say it again. This interaction is marginal because there is no other three-way interaction in which age and grip are embedded in it that it would be conditional on a third thing. That is possible to do, but I did not do that to you because this was enough. I did that to my other class, though. Be grateful you're not them.
They were worthy.
No, in longitudinal models, everything becomes a large interaction term. That's just how it works.
Oh, okay.
So,
Cool.
but yeah. So in terms of the moderation pattern, let's do each way here. This is the age slope for grip strength 9, right? So
Yes.
people of average strength. For every year older you are, your cognition score is predicted to be lower by about 1/3 of a point in people of average strength. Okay, that much we got. Now, what happens to it in stronger people? So I have a negative main effect of age. I have a positive interaction of age and grip strength. Which pattern is this? Your choices are more something or less something.
Yes.
We're narrowing it down from
Yes.
4. Go for it.
Less negative.
Yep, this is less negative, which means that the effective age is getting stronger or weaker as the moderator is higher.
Weaker.
Weaker, yeah. So I don't have my cheat sheet of GRE words to describe this, but I can make up a couple of them. So the deleterious effect of aging is mitigated in those who are stronger. How's that?
Too academic.
Too much? Age matters less in stronger people.
I like it.
That one? I like matters more and matters less as a way to describe slopes in sort of an everyday language kind of way. So aging is bad for you. It's less bad for you if you're stronger. How does that sit with folks? It works. So aging is bad for you is the negative slope, because presumably it's not good to have lower cognition. But this negative slope is becoming less negative by the interaction coefficient. So let's put the numbers in the sentence here. So I'll do this one for you, and I'll ask someone to try the next one. So in folks who have a grip strength of 9, this negative age slope is 0.33. If grip strength is 10, then it is minus 0.33 plus 0.12. So for every pound of grip strength as the moderator, the age slope itself becomes less negative by 0.12. So when we talk about the one slope, we vary the moderator of the other. So I'll say that one more time. For every additional pound of grip strength, the age slope becomes less negative by 0.12. It weakens, gets closer to 0. And that is significant, so we would keep it. All right. Questions so far? Thumb check? Everyone's up or lying. I don't care which at this point. Yay!
Mine is for bed and sleeping.
Yes. No, I'm just kidding. I actually do care if folks don't understand. That's why I keep asking. So this is one pattern. The grip strength slope is positive. So we know that the pattern has to be different. The grip strength slope is 0.62 in 85-year-olds. What happens to it in older people? Which pattern is this? Positive grip strength slope and a positive interaction term. More positive, less positive, more negative, or less negative?
More positive.
More positive, yes. So the grip strength slope is positive. So that's the first thing to recognize, is that that knocks out less negative or more negative, because it's not negative in the first place. The positive interaction term, combine it, is going to make it stronger. So the way I would talk about this is the grip strength slope of 0.62 does what, according to the interaction term? What's the end of my sentence? Becomes more positive by 0.12 per what?
Per year of age increase.
Per year of age in this case, because grip strength is the thing we're interpreting right now. So in English, being strong is helpful, more so if you're old. The benefit of physical fitness is enhanced in older people. Something like that?
I like it.
Now, these ones are specific to the zero values of the moderator, right? One thing that folks often do to try to describe, plot, and interpret interaction terms is to generate predicted slopes at other values of the moderator. Plus or minus 1 standard deviation is a popular choice. So I will show you how to do that. So there's a 3-step process to figuring out how to compute any kind of slope at any level of the moderators. Step 1, find the terms that have the slope in question. So this is the age slope that we want here. Step 2, factor age out, and what's left are the ingredients by which you form the slope. So in Stata code, I need 1 beta 1, so that's age 85 right here, and I need to fill in the value of grip strength that I want the age slope for. So the standard deviation in this data is roughly 3. So what I'm asking for then is grip strength slope at 6, because grip strength is centered at 9. Grip strength at 9, which is the one that the model already gave me, and grip strength of 12. So Stata folks, you're going to like this. If you can handle a reference to calculus, you can save some typing. These 3 lines are done all by this one. dy dx. So we're taking the derivative with respect to age. Did I say that correctly?
Yes.
Calculus was 30 years ago. It's been a minute. Yeah. Oh my God. Yeah, it was. Okay. I just got older in my own head.
Last time I used it or saw it was 20, but you're okay.
30 years ago. So I am asking for the values of the moderator for which I want the age slope. And so you can put in specific values or a range of values. So the way to interpret this is right here in the comment, from by to. Start from -3 in increments of 3 and go up to 3. So that gets me -3, 0, and 3 as 3 points. And so that one table then provides these here. So this table I think is instructive. Number 1, to make sure we understand the pattern. So the pattern above that we said was that the age slope is negative and it becomes less negative as a function of the interaction term. So for instance, at grip strength of 6, we have a significant negative age slope. It is still significantly negative at grip strength of 9. That's the one that was in the model. However, by the time you get to 12, it's not significant anymore. So that might cause one to ask, well, somewhere between 9 and 12, this thing shuts off. Wouldn't it be nice to know where that is? Like, what are the boundaries? The regions of significance? We talked about this like 2 or 3 weeks ago, maybe? Yeah, it was in a slide. We're going to see it again. Because why did I pick plus or minus 3? Because that was the standard deviation. But there's nothing special about these values. So rather than picking like all these different slope values to plot at, why don't we find the range over which these things matter or don't? Same thing with grip strength. The pattern of grip was that it was a positive slope that became more positive in older people. So to get the grip strength slope for any age, those are my ingredients. And I reverse the code in Stata. Now grip is the slope that I want, age is the moderator, and I provide a range of values. So this one line again replaces these 3 lines below it. So in younger people, so this is age 80, there is no effective grip strength. In 85-year-olds, there is an effect, and the effect continues to grow in 90-year-olds and be significant. Same question though, somewhere between 80 and 85, grip strength starts mattering. So where is it? And if you're like, my head hurts, can you show me a picture? Right there with you. Here's some pictures. Stata made these. And you can double click on these, by the way, when they pop up in your output and edit things, like change the colors, change the labels. So for instance, if I were making this plot for a publication, my x-axis would not be grip 9.
No.
I would put it in original grip strength. And I would label it like as, grip strength in pounds, and the center would be 9, for instance. The y-axis, linear prediction is never a good label for your y-axis. Predicted cognition would be a better one. So if we look at this plot shows what the effective grip is for people of different ages. And I've got the opposite on the other side. We'll just dial into this one here. So the red line is what was given by the model. That is the effective grip strength in 85-year-olds. And we know that that is significant. And then the other 2 lines were what we just asked for right here. So the blue line is for an 80-year-old, that slope is non-significant. The green line is for a 90-year-old, and that slope is significant. So somewhere between blue and red is where it turns on to be significantly positive. But what would happen, do you think, if we went even younger? If I went to 75, 70, what's the pattern going to do here? This is a gesture question. So this is what it is at 80, 85, 90. This way, right? Hang on. I got to do it this way. I need my other arm, that's why. There we go. There we go. See, I can do calculus. I cannot do spatial reasoning to figure out which way my arm should go. Okay? That's what I cannot handle.
That's your kryptonite.
That is. It absolutely is. Okay, so this is 80. This is 85. This is 90. So let's go this way. 90, 85, 80. What's going to happen if I get younger? Yeah. It's going to go the other way. Yeah. So at some point, it is predicted that this grip strength slope would turn negative. If you follow this pattern, right? It's becoming less positive, less positive, less positive. It's going to go negative at some point. So there may be some subset of our sample for which grip strength is actually bad for you. The question is, do we have people at that age, and where is it? The other plot shows the interaction from the opposite perspective, focusing on the effective age for grip strength as a moderator. So the red line is what was given by the model directly. That's the slope for age at grip 9. And the pattern is such that age matters less if you're stronger. So in weak people, grip strength of 6, we have a negative age slope. It's negative at 9, and then it's going to eventually become positive if you follow this tendency up here like this. So then the question is, do we have anybody for which age is actually good for you? Now, Stata folks, here's the bad news. There is no way to compute regions of significance that I could find on the internet that someone has figured out in Stata. I'm not saying it doesn't exist. I'm saying I could not find it. Just like R, people write essentially Stata packages. They're called addo files. And you can download them and install them inside Stata and use them like as functions. And we will use a couple of those in the generalized class if you stick around for that. So I was looking for someone who would have done this, and I couldn't find any. So there are, to figure out these regions of significance, there are certain values that you need, and if you are a Stata user and you want to be able to do this, I built you a spreadsheet. So in the download folder that goes with this example, there's an Excel workbook. One of the tabs is regions of significance, and these are the values that it wants you to enter. Now you might be looking at this and going, what is this thing? Well, this is a matrix. It is a square matrix, meaning that the rows and the columns are the same. And it is known as, it's a mouthful, this is the asymptotic covariance matrix of the fixed effects. You're like, what the hell is that? It's an estimation thing. Relevant to us is that the diagonal of these things is the standard error for that slope squared. That is a term known as sampling variance.
I was gonna say, isn't that a variance?
It is a variance, but it's not the variance of the outcome like we talk about in R-square. This is essentially the variance of what that slope could be across repeated samples. And so because if one slope turns out to be higher, then there has to be compensation, like another slope would turn out to be lower. What the slopes end up being have a relationship. So these off diagonal, that's what it's called when you're off the first diagonal here, these values are covariances among the standard errors. And you need the ones for the interaction term with the main effect as the covariances, and you need the standard error squared for each of the main effects and the interaction term. And note that these are really tiny numbers. What is it called? Like precision creep, essentially. Like you would want to retain as many digits as possible to get an accurate estimate, which is why it's better to not input things into Excel or calculators if you can help it. But I got the answer out of Excel, and I'll show you how to get it out of R. And here are the boundaries. So I found out that the age slope is one boundary for, as a grip as a moderator is 9, the other is 18 for the age slope. The grip strength slope, the boundaries for age is 70 and 82. So let's start with 9 and 18 and come up here for the age slope. That's this one. So let me see here. I lost it. Hang on. Age slope at grip 9 is one boundary. So then this right before the 9 one is where we would end up going from non-significant to significantly negative. If I continue to go up past the green, grip strength of 18 would be the point at which the slope turns positive. And I can do the same thing for the grip strength slope, but I'll show you the R code because I've got pictures that may work with a little bit better with that. So we're essentially finding the spots where the slopes turn on in one direction, become non-significant, and then turn on in the other direction. That's the boundaries of significance here that we're talking about. Okay, R folks, I don't want to leave you out of the party. Something I learned the hard way. R insists that your interaction terms go last. If you write them in some other order, it will ignore you and put them last. And then that means that all your zeros and ones for your functions to combine things will be in the wrong spots. So, it is last. By the way, you can save some typing. I deliberately do not show this to you, but in case you want to know, if I change this colon to an asterisk like that, what that means is give me the two main effects and the interaction at the same time. So it's like the highest term and everything that goes underneath it. I deliberately do not do that because at this stage I want folks to remember that you do have to have the main effects as part of the interaction term in your model. Stata will do the same thing, by the way, if you put two hashtags in. So then it's the main effects and the interaction all together in one piece of code. So less typing if you want to, but less transparency as well at the same time. Okay, back to R. So I'll ask a question for the R output that I didn't ask for the Stata output. So here's my model, F. My model's significant, right?
Yes.
That means I have significantly predicted cognition with my 6 slopes. Does this tell me whether age by grip improved the model significantly relative to just the main effects? No, this doesn't. Do I need to do like an F-test for that? To test the change in the R-square from the new thing I added? What do we think? Because I had to do that before when I added sex by age and sex by grip at the same time. We had to compute an F-test for the change in the R-square and ask for that as a separate piece of information. Do I need to do that this time for my one new interaction term? There's a hint. I don't. Why not? I can't read lips, I'm sorry. Say, I can tell you're talking to me, but it doesn't help. Now I got the 3 dots here. It's already a thing. Yeah, what she said. Now, we can't write that in our results section, but what we can write is, well, if this new interaction term is significant, then by definition, the change to the R-square that it created is significant. There's a 1-to-1 correspondence. And if you're like, well, but reviewer 3 wants an F, you find this t value and do what to it? Do you remember the relationship? How do you get from a t to an f if you have only one slope that you're talking about? I've mentioned this a couple times, but not very heavily. You square it. T squared is f. So that's why an F-test for the change in R-square would tell you the exact same thing as this T-test for the single slope. For one slope, there is a 1-to-1
And
correspondence.
that was also given above, correct, as the last line for the
Yep.
interaction?
Yep. If you want to do the math, 3.035 squared is 9.210.
Okay, so we could technically look at that line if there was only one interaction added.
If you're adding one new thing, the
Yeah, just
test of
one,
the one new
yes.
thing is all you need.
Just one thing. Okay.
Now, I still need to compute the change in the R-square. So that would be a useful thing.
Mhm.
So I went ahead and did it, just to make that point. There's my F. And then the change in the R-square is computed for me. I picked up 1% more of the variance. Woohoo!
Just do that 100 more times. No, sorry.
Yeah, I know. Those of you who are skeptical, welcome to the social sciences. Those of you from the physical sciences can roll your eyes at us, but this is a very realistic example, even though it's fake data. We try really hard to get each single percent because our data are messy and our constructs are fuzzy. So here are the simple slopes then R style. So this is slightly more annoying.
Mhm.
Do we remember what the zeros and ones are?
Multipliers.
Multipliers, yes indeed. So here's my equation, for instance, to get the age slope. So that means the first term is 0 because what does that refer to?
Intercept.
The intercept. Yeah, that's why in the R code, I always put the 1 there to remind myself that the first thing is the intercept, so I don't get off a row. So in this R code, all of these commands have zeros for the intercept. That's because I'm outputting slopes, and intercepts have nothing to do with slopes. So I will never need the intercept as part of my combination if I'm trying to predict some kind of slope. What I do need, though, in the first case is beta 1, so that's why there's a 1 in each of these spots, because I need one of those. And then the spot for the interaction term is where the value of the moderator goes. So I want the age slope for grip strength of 6, so I put in a -3 here, given my centering of 9. So on your last homework, if you get simple slopes or predictions wrong, make sure that you are entering centered values. That's a thing that people commonly mess up. Likewise, for the grip strength slope, I want to start with beta 2 in all of those spots And then I put in the values of age as the moderator that I want the grip strength slope for. So this last spot here takes on a different interpretation based on what you're asking for, whichever one is deemed the predictor versus the moderator. The moderator goes in the interaction spot. So I have my little function here to spit out the output and add confidence intervals. So the results match what we had before. So somewhere between 9 and 12 is when the age slope turns on. Somewhere between 80 and 85 is where the grip strength slope turns on. Now, for those of you who say, this looks really annoying, is there a better way? Yes. So Stata had the dy/dx. I found a package called reghelper that has a function that is called simple slopes. Terrible name, nice function. So with a little bit of trial and error, I figured out how to replicate this annoying code with this one. So I'm asking for grip strength slope at these values of age and the grip strength slope at these values, hang on. Age slope, grip strength slope, but the numbers are in the opposite spots here. So like this is the range over which I want to have grip, this is the range over which I want to put age, and I have no idea what SS test means, but I think it means spit out the p-values. I found this a long time ago. So this output up here is replaced by this. So this one line gets you all 6 of these. Then we get into predictions. So the analog to margins, I found a package called prediction that will do this as well. So it wants to know your model. Type equals response is not yet relevant, but what that means is just give me the predicted cognition in the original version of the outcome. In generalized models, there are other choices that will become relevant for that. Then you tell it what you want to hold constant and at what, and then where you want to go over things by. So for instance, this option does from -3 up to 3 in increments of 3, and so forth for this one. And then I made a plot. Now it threw this warning message. Whenever you see red, by the way, in your R console, something went wrong. Red is mad. Same thing is true in SAS. It says, in check values data, comma, at value for age 85 is outside the observed data range. Any guesses as to what that means?
You have a value outside of the inputs that you use to create your model?
I have a prediction for a case that doesn't exist in my data, is warning me about. Like I've extrapolated too far. Because I went ±1 standard deviation on both variables. So how likely is it that you would have like a super young but super weak person, but someone who's also super old and super strong? Like to the extent that these variables are correlated, you're not going to have all the possible combinations. And so it's warning me about that. But that's okay. I can live with that. And look, I made pictures. They're just backwards. This is age and this is grip. And for whatever reason, the blue line shows up as black in the legend and I can't fix it. So, do you know how I would fix that? I would take a tiny little line object in Word and paste it over it. Like, or I'd do this in Excel. The Excel workbook that I gave you in your download folder has a plot in it as well. And so you can see how you could make those things work. Now, regions of significance is the last piece of this here. Here again is the asymptotic covariance matrix of the fixed effects. There is an option called vcov within R that will spit that out for you. So I did that and bolded the ones we're going to need. And there is, I think, is it the reghelper package? I'm not sure if that's where this came from or not, but I found a function for regions of significance. And the people who made this up, no. So Johnson-Neiman is a thing that was like invented in the 1930s. I don't even remember what it was for. And of course, it's named after the people who invented it. But somewhere along the line, someone figured out how to hack what they developed for this purpose.
Cool.
Yeah. So regions of significance, this is a synonym for it. So it wants to know what model you're talking about, which variable you're designating as the predictor, and so note that this is in quotes, so it needs to be case and space sensitive and match what it's called in your data set. Which variable you're designating as the moderator, how many digits of precision you want to be outputted, and they have an option to make a plot, but every time I tried to run it, it broke my computer. Like R froze and I had to like start it over again. So don't make the plot, would be my recommendation. So, and this is what it spits out. When grip 9 is outside the interval, the slope of age is p less than 0.05. So you're like, what? Well, step 1 is to change this interval back into the original metric. So I added 9 since we centered grip strength at 9. And this translates into the following. The age slope will be significantly negative if grip is equal to or below 9.665 pounds. It will be non-significant between 9 and 18, and after 18 it will be positive. So if we go back up to the plot here, it is as right around red, essentially, since it's 9.6, is where it becomes significantly negative. And if you follow this up, it would be a grip strength of 18, where the line would go positive instead. Does that make sense? Like if you, it's like this and it's gonna go like that. Probably the wrong arm though. Now the question is, do we have anyone in our sample like that? So R does help you with this. It tells you what the range of your variable is. So in this sample, we don't have anybody like that, but I have, in the example write-up that I did, I commented on this. So for instance, given the range of grip strength from 0 to 19 pounds in the current sample with a mean of 9, the effective age is expected to be negative for about half the sample. Anybody with grip strength below 9.67, it'll be non-significant for the other half between 9 and 18, and the effective age is expected to be positive for almost no one. So 19 is the highest value, so that one person would have a positive effective age, but that's it. So that would be, in terms of the utility of these values, it's useful to find where they are, but that only has meaning if you compare those numbers back to your sample. And so then you can think about like 2/3 of the sample would have a significant effect and 1/3 would not. Like that gives it a little bit more context. And so then I plugged in those specific values into this thing so that you could see what happens. So the age slope at grip equals 9.665 is negative, and the p-value is right at that significant. And this is where it turns significant the other way, a positive number. So what this approach is doing is rearranging the t-test for your slope to figure out what the slope values are, where t is greater than 1.96 as the cutoff, using infinity degrees of freedom for 95%. So that's why these are exactly 0.05, it's because that's what this algorithm is doing, is finding the point at which this happens. The other one then is, if I have grip strength as the slope and age as the moderator, those are my points, my regions of significance. So the grip strength slope will be significantly negative in people who are younger than 70. I don't have anyone in the sample like that. Non-significant between 70 and 82, and significantly positive after 82. So then that gives some context to these pictures, like you could show a region, like a shaded area would probably be an effective way to convey those onto the picture if you want. Okay, so lots of that. Here's my write-up of this thing, so you can see how I would describe that. Okay, how are we doing, folks? Reasonably okay? Ish? For a Thursday at nearly 3 o'clock? I understand. I'm right there with you. So this model is not as bad as it could be. Let me go back to where the model is. Let me find it again. Because There we go. These are both linear terms, and so it only takes one interaction term. What if I wanted to examine an interaction involving dementia group? If I wanted to do that, how many interaction terms do I need to add?
Which one are you using?
Well, dementia group is both of them.
No. I mean, are you interacting with age, gender, grip,
In
any or all of the above?
In this example, that would not matter because each of these is characterized by one slope. But
Okay.
let's say gender. If I need gender by dementia group, how many interaction terms do I need to add? Got one vote for 2. Simple slope test. Thank you. That makes sense, actually.
Maybe three.
Remember what we're thinking. Maybe 2, maybe 3, but definitely not 1, right?
Right.
So here's the logic.
Okay.
If it takes 2 slopes to differentiate the effect of dementia, then it takes 2 interactions to see how that effect changes as a function of a third thing.
Gotcha. Would it make sense to find interaction between those two?
These 2?
Yes.
No.
Then that's why. Then 2 is why. Okay.
Yep.
Okay.
So we're going to do that one next, but I wanted to show the logic by which that is. Apparently PowerPoint doesn't want to play either. It's all blurry, like, no thank you. We did that one, I think. Yes, so let's do a little review before we jump into that, shall we? This is slide 18 of lecture 5. I literally stole these same exact slides from lecture 3. So you've seen this before, but it's been a minute. So I thought we'll bring it back. So categorical predictors, we cannot put in as numbers because they're not numbers, right? So if I have this variable that is which group are you in, and in my data it's coded 1, 2, 3, 4, will R or Stata let me put in a slope for 1 versus 2 versus 3 versus 4 for group? Yeah, it'll let me. Does it mean anything at all? Nope. Would ChatGPT estimate a slope for these 4 numbers? Yes, it would.
Maybe. Oh, okay.
Yeah.
I haven't tried it. I just say that's what I'm throwing out a maybe.
Yep. Someone test this for me. Ask ChatGPT to estimate what the R code would look like to control for group and see if it does it correctly. That'd be one question I want to know. My guess is that it may not get it right, but we'll see. So treatment group is 4 categories here. That means I need to create 3 new predictors where I am differentiating one group from another within each. So I decide, based on my coding scheme, who's going to be the reference category, the reference group. I'm going to pick control, and that means that I zero out the values for those 3 new predictors if the group is control. My first predictor is going to capture how treatment 1 differs from control. My second one, how treatment 2 differs from control, and then treatment 3 differs from control. So this is indicator dummy coding, as they call it in your textbook. Cool. So how many fixed effects are in this model here on slide 18? How many fixed effects in total? As my nose is running because our classroom is freezing. How many fixed effects? The answer is either 3 or 4, right? Y'all are like, I'm not sure which one it is. I didn't say fixed slopes, I said fixed effects. 4. How many groups do we have? 4. Is that a coincidence? No. So if you have as many fixed effects as you have groups, then you will perfectly recreate your group means. It is a term called saturated. Essentially, you've put everything in that you need to differentiate these 4 groups. And the reason that I only need 3 predictors is because the 4th is redundant. If I know the difference of each group relative to control, then I know I have everything I need to figure out each of the group means, because beta 0 tells me what control is. Each of these tells me how that group differs from control, and so I can add them together. Yep. So the model implied means would be given like this. Control is just beta 0. Treatment 1 would be an additive combination of these two, treatment 2 and treatment 3. If the model tells me how each mean is created, and it just did, it also tells me how all possible differences are created as well. So let's put some numbers on here. Let's say the control group is 10, treatment 1 is 12, treatment 2 is 15, and treatment 3 is 19. So control versus treatment 1. The treatment 1 group goes first because we're treating control as the reference. So the reference is what's subtracted. So I have beta 0 plus beta 1 as how that group gets its mean, because D1 turns into a 1 if I have treatment 1, versus beta 0, so it's just beta 1. So then that coefficient would end up being 2, because that's by how much treatment 1 is greater than control. Same thing for control versus treatment 2 and 3. So 3 of the differences are given directly as model parameters. The others are implied, but we got to ask for them. So if I want to know amongst the treatments, I start with what the mean is for treatment 2. I subtract from it what the mean is for treatment 1. The beta zeros cancel, and I'm left with beta 2 minus beta 1. So that would be 5 for this difference minus 2 for this difference gets me 3. So treatment 2 is greater than treatment 1 by 3. That is beta 2 minus beta 1. Same thing with treatment 1 versus 3, same pattern, and 2 versus 3 as well. So we have all the differences as what the model says. We don't need to worry about that. Now this is main effects. This unit's about interaction terms. So let's say I wanted to examine whether treatment effects depended on age. Do you think that some treatments might be more effective in younger people and some might be more effective in older people? That seems like a reasonable thing. How many interaction terms do you think I need to answer this question? Five? Is that 5 would be a lot. How many slopes did I need to differentiate my 4 groups? 3? Yep. So how many interaction terms am I going to need? 3. Yep. Each of these needs to interact with age. So my model would look like this. So now, this would be a situation in which, to answer the question, do the effects of treatment differ by age, I have to somehow lump together beta 5, 6, and 7, because they all work together to answer that question. So I would need to request an F for that. This is not one where I can say t squared is F, the end. The rules of conditionality also still apply. So beta 1, beta 2, and beta 3. These are the main effects, simple main effects, conditional main effects of group differences. Given the interaction terms, who are these group differences for? They're conditional, right? These are group differences due to treatment in 85-year-olds specifically, because that would be the point at which the new interaction terms drop out when age 85 is 0. Likewise, this beta 4 for age, that's not just the effect of age, that's the effect of age conditional on the interactions. So for which group do we think? Yeah, when would these go away? When all 3 are 0, we're talking about control. Yep. So it's just a higher order of complexity, but it's the same concepts. So this may be painful or helpful, I'm not sure which. We'll find out. So here are my predictors. This is how they are coded. Here's my model. Here's how I would get the predicted group difference for any age and the expected age slope in any group. Okay. Effective age starts with beta 4 for the main effect. Then I need all the interaction terms because they all have age. And so I would turn on the D dummy code variable for each of the groups that I want that for. So each of these will be a linear combination except for control because that's what beta 4 means directly. So this is the kind of thing you get to practice in your homework. But there's only 2 groups, so not 4, because I'm not that mean. Control versus each of the other ones. So what is the effect of any kind of treatment versus control at any age? Same logic, we start with what is the treatment effect, then we figure out how it changes as a function of the interaction terms with age as the moderator. So I can figure out what the difference would be at any age this way. These ones are the painful ones. I have the model implied differences among treatments. Because each of these then is a piece of information. So like this would be from here minus that one. So it's ugly, but it's doable. So interactions can be tested if you have variables that take more than one slope. So for instance, if I have my piecewise education model from example 4, remember that one? We had 3 slopes, less than high school, effective graduating high school, and then effective some kind of postgraduate, whatever. Do you think the effect of education differs between men and women in terms of predicting income? Probably, sadly. Could I test that? Sure, just like that. I just did. One of my favorite things to say. So I have my 3 piecewise slopes here, my main effective gender, and then the 3 interaction terms. So because it took 3 slopes to delineate the effect of education on income, it takes 3 interactions to say how the effect of education differs as a function of some moderator. Same logic, just a different context. So I would lump together the 3 interaction terms to answer the question, does the effect of education vary by gender? My simple slopes would tell me the effect of education specifically for men. The interactions give the difference in the education slopes for women. And so then I can figure out what they would be for women by adding up each of these as linear combinations. But what if I were not in a simplistic binary world of gender and I wanted to add a 3rd category? Could I do that? Sure I can. So I would need another beta here to delineate another group, so men versus some other group, and then how many more interaction terms would I need? I need 3 more. Yep, so I'd need 6 interactions then to answer the question, does the effect of education on income differ by gender? By the way, when you learn this in other contexts, like in ANOVA language, the idea of lumped together slopes that all refer to the same idea is omnibus. So that would be like, if I go back for the categorical one, come on, go back. Like the beta 5, beta 6, and beta 7 here, that would be the omnibus interaction of age and group. Beta 1, beta 2, and beta 3 would be the omnibus effective group. That's a word people use. Lumped together is what I say, but that's not something you can put in a results section, or should. All right, let me go out of that for a second here. I think that's, yeah. Yeah, okay, yeah, we're good. 3 more slides and I'll let you go. How's that sound? We won't do another model today. 3-way interactions, we talked about this, right? PowerPoint's like, no, we didn't. There we go. So with generic variables then, if I wanted to test a 3-way interaction, I would need each of the two ways that go underneath it. In order to test those, I would need each of the main effects. So the rules are the same. Simple main effects make the predicted outcome higher or lower. So as W increases, beta 1 says that Y goes up or down. The end. But each of these is conditional on the stuff it interacts with. So that means that like this beta 1 slope for W, this is specifically when both X and Z are 0, because it's conditional on all of them. The two-way interactions work the same now. So X by Z in this model is marginal or conditional? Beta 4 here. Is this marginal or conditional? Yeah.
Conditional.
It is, because this term now shows up in here. Same logic. So beta 4 is how X moderates Z if W is 0. Beta 5 is how W moderates Z if X is 0. And beta 6 is how X moderates W if Z is 0. Then we get to the three ways. And you know what? There's only 4 kinds of three-way interactions too, and actually maybe just 2. But what they operate on are the two-way interactions. So the pattern of moderation implied by the two ways becomes more positive, less positive, more negative, or less negative by the three-way. It's the exact same thing. The three-way interaction then would be marginal because that's the highest order. So here's what that would look like to figure out what the main effects would be. So they would be built from the two-way interactions and the three-way. And these are simple two-way interactions. I shit you not, that's what people call these things. If that is not a contradiction in terms, a simple two-way interaction. That just means conditional. So each of these then would be conditional on the third thing in that case. So there's my intermediate summary. Y'all know how to do moderation now.
We've been moderated.
Yes. Yay, yes. We've all been moderated. The rest of this is changing gears, but it's like a special topics thing that I just figured I wanted to throw in here. So that will be Tuesday, as we'll hopefully finish this, and one more model. And then next Thursday will be the caveat lecture, and then we'll be done. Woo. Yes, all right. Questions before we call it a day and a week? No. All right then, so you can be working on your last homework, you can be submitting your evaluations, and you can be having a good weekend. How about that? Yeah. Thanks for being here. Stay warm. Take care of yourselves. Bye for now.